we are sketching the graph of this function. Now, since this function is an improper rational function, so we can divide the numerator by the denominator. All right, after division that you have a quotient and plus a remainder. Okay, that form helps us to sketch the curve later. Okay, then we find the derivative. The first derivative. Well, we save time and not do the detail, but I suppose you know how to find a derivative. When the derivative equal to 0, the x equal to 0 or minus 3, right? That's easy. And then we take the second derivative and quotient rule, chain rule, and simplify. You get this. Then the second derivative is 0, then x is 0, right? Then asymptotes. Now, when x is approaching to 1 from right, and x is close to 1, right? Which is x is 1.00 something. Yeah. X approaches the negative 1 from the right. So this one is close to 0. If the denominator is almost 0, so the y value is very large. Now, since this is square, so the overall value is positive, right? Positive infinity. So is the limit when x approaches the negative 1 from the left. And this is also close to 0, negative. After square is a positive small number. So this quotient will be a very large number. So it means that when x approaches negative 1, y will be infinity. X is equal to negative 1 is our vertical asymptote. Then we know that we have 0, minus 3, and the negative 1 are the 3 points of x that we need to discuss. So this is a minus 3, this is a minus 1, this is 0. Okay, these 3 points divide the whole interval into 4 sub-intervals. So this interval is minus infinity to minus 3. This is minus 3 to minus 1, and then minus 1 to 0, and 0 to infinity. Right? We are sketching the curve. We need to discuss the shape of each sub-intervals, So this is why the derivatives play an important role. So this line is x, and x plus derivative, second derivative, then y. Now we need to know that the signs of a derivative in each interval. So in this interval, I just pick up a number, say for example, minus 4, or minus 10, or minus infinity, or minus a million, and so on, into the derivative function. Then we get a positive. We just need a sign. We don't need a value. We don't need a value, but we need a sign. When x equals minus 3, it is a 0. And in this one, we pick up a number, say minus 2, and put it here, you get a negative. At the negative 1 is not defined. And pick up, say, minus 1.5, minus 0.5. So into the derivative, then we get positive. And this is a positive. This is a positive. Similarly, we do the second derivative. We pick up a value, put it in second derivative, and I have a negative. Minus 3, put it there, we get a negative. And pick up a value, minus 2, put it here, it's a negative. That negative one is not defined. In this interval, we pick up a value, we put it here. This is a negative, right? So the overall is a negative. At the 0 is 0. Here I pick up a million, so this is positive. And then, yeah, that is interesting. Okay, a function, the second derivative is positive. Second derivative positive. The shape looks like this when the first derivative is positive. No, the first derivative is negative. It's decreasing, right? The first derivative is positive, increasing. Second derivative is positive. Then the shape of the curve looks like this. And this is the first derivative 0, and this is the minimum. And here, second derivative is a negative, and the shape of the curve looks like this. First derivative positive this way. First derivative is negative. This looks like the curve. And when first derivative is 0, is the maximum. See, these two pictures and summarize all the shapes of curve, depending on the sign of the derivatives. Now, okay. So let's see. Negative, positive, negative, positive. So that's the shape. Negative, negative. So that's the shape. Okay. At the negative 1, the function is not defined. So function is not defined. Here, negative, positive. Negative, positive, that's the shape. Okay, that's the shape. And positive, positive. Positive, positive, that's the shape. Okay, that is a... Okay, the curve, okay, let's see later, okay. Now, we have still one thing to discuss, that's the oblique asymptote. When x is approaching to infinity, this will be 0 because this second power denominator, first power numerator. So the fraction value is approaching to 0 when x is infinity. So the whole value of y is approaching to this. Is approaching to half x minus 1. Half x minus 1. But this is a positive number. No. When x approaches negative, x is a negative number. So this is a negative number, but very small. Half x minus 1 and minus plus a very small negative number. So y is approaching to this straight line from below. Okay, because it's a negative number. At the same time that when x is approaching to positive infinity, and this will be very small number. Second degree, first degree, right? This is a very small positive number. Therefore, y is approaching to this and plus a small number. So this is a half x minus 1 from above. X, okay. Sketch curve means we collect the information And from those pieces of information, we sketch the curve, right? Now we can do the sketching. From infinity to -3, the curve looks like this. And when x approaches to infinity, y is approaching to this straight line. This is half x minus 1. This is the straight line. So y is approaching to this line from below. So it looks like this, right? It looks like this. Now let me use this pen, so I'm not sure, okay? That means closer and closer to this line when x is a very large negative number. Until this point, right? -3, 0. -3, -3. We put -3 here. We find the y value. When x is -3, we put it here. We calculate this value is -27 over 8. So that is the number. This is -3, right? A little more than -3. So that's the number for this one. Okay, so that's the shape of the curve. This is the shape of the curve. This is the shape of the curve. Okay. Then from -3 to -1, x to -1 is infinity. So it looks like this, right? Infinity. When x is approaching to -1, y is a negative infinity. And the shape looks like this. So the curve looks like that. Very good. Then from -1 to 0, from -1 to 0, the curve look like this. The curve look like this. So it looks like this. Let me use the red one. So because when x approaches to 1 from right, it's infinity. See, infinity. And the shape is this. This is the shape. And at 0, y is 0. At 0, y is 0. Right? And after that, from 0 to infinity, this is the shape. And when x approaches to infinity, y is approaching to this number, this straight line. That means y is approaching to, this is a curve, close to this straight line when x is very large. And the shape is this. So the shape is this. Well, this. Wow, it's a beautiful line. Let me repeat again. This is the shape from 0 onward. And this is asymptote, the oblique asymptote. When x is very large, y is approaching to this number from above. So this will be overall picture. Okay? Now, let me say something here. Look, the derivative is 0. The derivative is 0. That means at this point, at 0, the left-hand side, the tangent, the slope of tangent is 0. And at the right is also 0. So See, the curve looks like this at 0. Both sides, the derivative is 0. Tangent. The derivative, no, sorry. Both sides, the slope of the tangent line are 0. So this is what I meant. Okay, this 0. The curve looks like this. One shape. Doesn't no two. Only one shape, and close to 0 is tangent 0, and after at this side, the tangent is always 0. Gradient, the slope is also 0, and then this is the shape, right? So this obviously point inflection. So this point is a point inflection. Although the first derivative is 0. First derivative 0 does not guarantee is the maximum or minimum. But here, it's point inflection rather. And this point is a maximum. Yeah, maximum. So this point is a maximum. Very nice curve. Very nice way to sketch the curve. Okay, I just want to emphasize again, this is the shape. This is the shape. And at 0, the gradient of tangent is 0. At this side, the gradient tangent is also 0. And the vertical asymptote, oblique asymptote, and maximum, and the point inflection. Okay, so this table is a very nice summation, summary, very nice summary of the derivatives and the shapes and the points, maximum or minimum of point inflection and so on. See, I think this is a very nice way to sketch the curve. I have 8 videos talking about the sketch of the curve. Now you can find it in YouTube. Thank you for your watching.